Good morning, one and all. Today we discuss about electric field. Electric field. Okay, that is indication of electric field. It is denoted by E. Electric field. Going to this class, we will discuss in the previous class. The previous class is nothing but principle of superposition or force between multiple charges. Multiple charges or forces between the multiple charges or principle of superposition. Principle of superposition. Okay, the forces between the multiple charges are principle of superposition. Okay, we will discuss forces between the multiple charges. Okay, when forces is occur in a two or more charges is there, suppose q1 charge here, this q2 charge here, we can form a force. Okay, that is separation between the two charges is 4. That is force is equal to Coulomb's law, k q1 q2 by r square. Okay, that is nothing but c, that is F is equal to 1 by 4 pi epsilon naught k q1 q2 by r square. This is a Coulomb's law. The force between occur between the two charges. Okay, suppose in two charges, if that is multiple charges having, we can consider a number of charges in a system. One system having number of charges q1 q2 q3 q4 q5 like that up to n. We can write down, we can observe the forces is occur. It is force, it is sum of the individual force of the resultant force is equal to sum of the individual forces. Suppose here, suppose 3 forces or 4 forces q1 q2 q3 q4, like what is the force occur at q1. Okay, this distance is r12 or r21, r21 or 12. That is distance. This force is occur, repulsion force, both will be in the first two, that is F12. F12 is nothing but force on a q1 charge. Okay, the force okay, that the force is on a q1 charge due to second charge, and also from the q3 to q1 charge force F13, that means force on a q1 due to third charge. The force due to charge 4 due to q1 charge, that is q14. That is q14 is like that. These forces are the occur. The resultant force or net force is equal to, that is on a q1 is equal to f1 is equal to sum of the individual forces of the individual forces, like this. Again, we can having number of forces f1 f12 f13 f14 like this. And also we can write, suppose the having the system having only 4 charges, that is we can adding the only 3 charges. Then is the it is the charge is from this end. Okay, that is the multiple charges having, that is we can adding the number of forces, that is the sum of individual forces, nothing but individual of the resultant force is equal to sum of the individual forces. That is a superposition of principle. Already you know, I explained. This can be explained in the write down in the form of f1 f2 and 3. Okay, f12, suppose f12, can here f12 is nothing but 1 by 4 pi epsilon naught q1 q2 by r12 square by r12 cap. Suppose f13 is equal to 1 by 4 pi epsilon naught q1 q3 by r13 square r13 cap. Okay, in the case of 413, you can adding the number of forces. This is can be written as the resultant force of the force at q1 is equal to F1 is equal to q1 by 4 pi epsilon naught, that is constant. Only variation is summation of I is equal to 2 to n up to n charges, that is q1 by r1i square into r1i cap. That is the forces due to at one charges due to all charges, that is multiple charges, or principle of superposition of given charges. This is the okay. Now we will discuss electric field. Electric field is nothing but space around the electric charges up to which its influence is known as electric field. Electric field is nothing but, here we can taking plus q charge. Plus q charge is there. Okay, that is a source charge. Source charge means it can be producing the electric field. Okay, it can be producing the electric field. Okay, it can be q naught. Q naught is the q is the source. It can be producing the electric field or electric lines of forces, that is electric field. Okay, that is electric field. It can be producing the electric charges. Suppose initially, suppose plus q is there. Okay, here q naught plus q naught. Q naught is the test charge. Test charge. The test charge is nothing but that is affected. Test charge is the affected charge and the source charge. The test charge is nothing but the affected of the source charge. This it can be here due to q1 it can be occur, and also that is q1 charge. Here this can occur the force, that is q naught charge. Here q naught charge, sorry, here q naught charge, here q naught charge, like this. Okay, this influence of test charge. The source can be producing the electric lines. Okay, that is due to electric charge. It is the charge can be influence the electric field q naught. It can be producing the electric lines or electric field. Okay, suppose this is nothing but electric field radially outward. Here radially outward. Radially outward. Okay, that means the rays electric field of lines or electric fields goes from plus to minus. The electric field. Okay, that is electric field indication or direction. Okay, that is minus to, sorry, plus to minus when the charge having plus q, that is source, can be producing the electric lines or electric field. Okay, the test charge can be, it can be observed or affected by a source. Okay, that is the test charge. The test charge is a very small charge. It does not create any field, any charge. That is, it can be chosen as at q naught tends to the limit. The q naught tends to 0. That means it is very small. The every charge create a electric field, either negative, either positive. It can be create the electric field in a space around itself. And also one point here, every charge creates an electric field in the space around it. That is, suppose one space or one body, one system, that is q1 q2, that is a plus 1, here q2 plus 1, another charge is plus minus q3. Okay, here I know what is the force between the two charges, that is 1 by 4 pi epsilon naught q1 q2 by r square. Suppose between the two charges, suppose q3, that is you can write down 1 by 4 pi epsilon naught q1 q3 by r square. Okay, that is already you know between two charges or multiple charges. Okay, the system or surface space having the effect of electric field. Suppose in the place here minus, we get attraction to each other. Suppose between the two forces, we get the repulsion. Already you know the properties of charges, that is minus plus, we get the attraction, and like charges get attraction, like charges get repulsion. Okay, that is a one space. Okay, out of space, that is suppose one charge is not affected by a system or space. It is not affected by a system, only surround around the some space. The electric field, every charge on a system, suppose here q1 q2 q3, we get electric field, that is e1 e2 e3 only. Not suppose q4 is there in the far away at surround space, it is not due to electric field, that is net total electric field is equal to q1 e1 e2 e3. Okay, that is a net electric field due to of a in the space or area in a system or closed loop. Okay, not affected by a other charges, only closed loop or body on system or space. The electric field already you know relation, that is E is equal to F by Q. Okay, that is the relation, already you know expression. The forces, the one having one body or system closed loop having number of charges, it can be producing the force. Okay, the forces can be occur between the two charges, but here electric field get the occur when one charge having source charge, another one is test charge. Test charge is a very small charge, that is affected by a source charge. Okay, suppose here q1 q2 q3 q4 q5 like up to q9. Okay, 9 charges is we get the electric field e1 to e9, that is we get the resultant electric field. Okay, not affected by a other charges around the space only. The electric charge create the electric field in the space around it, body or system or space, we get the same, that is proportional. Electric field is proportional to the force or inverse proportional to the charges. Okay, that is the relation. So now we can explain the. Okay, suppose we can using minus charge, minus test source. Okay, the magnetic lines of forces are coming. The magnetic lines of forces coming. Okay, that means here minus q charge test is coming like this. It is minus q naught is test charge. It can be attraction minus q naught. It is a source. It is a test charge. And also here q naught is the test charge. It is the attraction, sorry, repulsion, here attraction. Okay, minus plus can be attraction, that is number of lines of forces is attracted to the minus q charge. Here plus repulsion, that is lines of forces is going from minus charge. The electric field direction, that is minus to plus charge, minus plus q to minus q. Okay, that is repulsion, that means lines of magnetic lines, electric lines are going from plus q, that means here radially outwards, that means electric field away from it, the electric field direction away from it, the electric field is in this direction. Okay, electric field is a vector quantity. Okay, suppose here the electric field direction is like this. This is the electric field direction when we having minus q charge, that is radially inward. The electric field is radially inward, that is electric field towards q, electric field towards minus q. Here electric field towards plus q. Okay, okay, here electric field up to minus q plus q, we can observe the what is the electric field extend up to infinity. Electric field is extended up to infinity. Okay, that means here the electric field lines are coming from infinity to minus q. Okay, and also in the case of plus q, the electric field lines is going from plus q to up to infinity, that means long distance. Okay, that is electric field lines are going from plus q to minus q. Okay, here rays are coming from infinity to minus q, here rays are going from plus q to infinity. Okay, that is okay. We can now we will discuss the intensity of electric field. Intensity of electric field. The force experienced by a unit positive charge. Unit positive charge and a test charge is placed. Test charge is placed at that point. At that point is as known as intensity of electric field. Okay, that is intensity of electric field due to a point charge. That is, a point charge is nothing but one text charge. E is equal to force on a point charge. Force on a point charge by test charge. Test charge is equal to, that is F by Q naught, or already you know force charge. Force is nothing but E is equal to force charge what? Q1 K Q1 Q2 by or Q naught by R square by test charge Q naught cancel, that is K Q1 by R square. Okay, kq1 by r square. That is the electric field. Electric field intensity E is equal to k q1 by r square or f by q naught. That is the electric field intensity. Okay, that is when we get test charge is equal to 1 coulomb. That is E is equal to f is equal to E. That is intensity is equal to force. Okay, electric field is nothing but k q1. Already you know relation intensity of electric field, that is force on point charge by test charge, that is f by q or f by q naught. F already you know force occur when between the two charges, that is f is equal to q1 q2 by r square, k q1 by q2 by r square. Okay, is here f is equal to force by test charge, that means force f by q. Here q naught cancel, that is electric field is equal to k q1 by r square. That is from this equation, that is electric field is proportional to the charge, source charge. Okay, and also the electric field inversely proportional to the distance from the source test charge. Suppose here one test charge is there, here we get the source charge, it can be producing the electric lines or electric field. Okay, influence of the test charge, it is a test charge is the affected charge unaffected by a source. Okay, we can write down E is equal to k q1 by k q by r square or f by q or k q by r square, that is electric field. Okay, according to this relation, that is square law, inverse square law, that is variation of electric field with the distance. Here electric distance or separation, here electric field already you know in a square law, inverse square law, that is f is proportional to the 1 by r square. Force electric field direction outward, and also force direction also there. Okay, that is f is E is equal to f by q. When we get test charge having 1 coulomb, the electric field is equal to force. Okay, that is inverse square law, electric field and separation of the distance or separation of distance, that is like this. SI units of electric field is Newton per coulomb. Okay, Newton per coulomb is f by f, Newton q charge coulomb, or volt per coulomb. Okay, electric field in the form of vector form, already you know force in the form of vector form, k q1 q2 by r12 square r12 cap. Okay, in the form of electric field, f is equal to f by q, that is k q by r square. Okay, in the form of r square, in the form of vector form r cap. Here you know r cap is equal to r bar by mod r. Okay, in the case of electric field, it can be written as here k q by r mod r square is equal to, according to this r cap is equal to, okay, substitute this one, r bar by mod r, that is electric field k q by mod r cube. That is electric field, the electric field in the form of vector form, E is equal to k q by mod r cube by r bar, or electric field E is equal to k q by r square r cap. Okay, it is in the form of vector form. Okay, now we explain the electric field due to system of charges. Electric field due to system of charges. Okay, electric field due to system of charges. That is, it is nothing but principle of superposition. Same in the case of, in the previous case, the electric field, that is means force is occur between the two charges. Okay, that is F is equal to Q1 Q2 by R square. Okay, that is force in a form of vector form is a K Q1 Q2 by R12 square into R12 cap. And also we already explained that is multiple charges. The system having multiple charges, what is the force? The force is nothing but already explained like this. The force is nothing but sum of the individual of the forces. F1 is equal to F12 plus F13 plus F14, like this. So the system having only 4 charges. Suppose if the system having n charges, the force at Q1, that is force at Q1 net charge is equal to Q1 by 4 pi epsilon naught I is equal to 2 to n Q1 by R1 square into R1 cap. This is a vector form, the multiple charges having forces. And the same phenomena in the form of electric field, the field system having number of charges. The number of charges system having Q1, Q2, Q3 like that up to Qn charges. That is in the form of distances vector, that is R1, R2, R3. Okay, we get the what is the E1R, E2R, E3R. Okay, that is some of the individual electric field. That is according to the total distance. Total electric field is equal to E1R plus E2R plus E3R up to system having only three system having only 3 charges. That is Q1, Q2, Q3. Okay, in the same of like forces. Okay, the net electric field is equal to E1R, E2R. That is a principle, that is a electric field due to system of charges. Or diagram, that is Q1 plus Q1 charge plus, suppose here minus Q2 charge plus Q3 charge. That is at O it is a plus 2 charge, it is electric field can be exhibited, that is E1 due to electric field E1. Okay, suppose here electric field, it is attraction, that is direction of electric field is upward, it is E2. Suppose here E3, electric field is E3. Okay, these are only 3 charges. The net electric field E1, net electric field is equal to E1R plus E2R plus E3R. Okay, that is due to first charge, the electric field in this direction outward. Okay, in the case of minus, due to second charge inward. Okay, in the case of third charge, that is plus Q, that is inward, that is radially inverted due to third charge, due to first charge. Radially inverted, it is outwarded. E1, E3 is the outwarded. Okay, that is due to plus charge. That's electric field here, plus to minus. Okay, in the case of minus, that is attraction. Okay, here ET, that is total electric field is equal to, here already you know, suppose E1R is equal to K Q1 by R square. Okay, R square. Suppose here E2 is equal to E2R is equal to K Q2 by R square. Okay, okay, this is the sum of the, suppose E3 is equal to K Q3 by R square. Okay, we can adding the number of electric field E1, E2, E3 according to equation. This net electric field is equal to sum of the individual of the electric field due to charges, that is E1 is equal to K Q1 by R square plus K Q2 by R square plus K Q3 by R square. Field Et is equal to, here suppose distance is changes, there is R1 square, here R2 square, R3 square, the distance is R12, here R12, here R13. Suppose you can write down in the form of total electric field. Here K is the constant, summation of I is equal to 1 to n up to n charges. Suppose here system having only 3 charges. If system having n charges up to n, you can write down K Qn by R 1n square is 1 3 1 2 R1. Okay, here you can simplify according to in the form of forces. Same, the electric field also write down here Q1 by Qi by R1 R1 n R1i into R1i cap. This is a net electric field in the form of vector. And also you can suppose you can writing at a certain point P, that is electric field due to at certain point P, that is E is equal to 1 by 4 pi epsilon naught. You know already K is equal to 1 by 4 pi epsilon naught, summation of I is equal to 1 to n Q1 by R1P RIP into RIP cap. This is the vector form of the electric field, the system having more charges. Now we can explain the one problem on a basis of electric field. Okay, suppose we can taking one charge having 1 microcoulomb, another charge having -2 q having -2 microcoulombs. Okay, this is a separation having 2 centimeter, that distance between the two charges. Okay, if one at a certain midpoint, the P at P, what is the electric field at the center of the two charges, midpoint, that is here 1 centimeter from here to here also 1 centimeter. What is the at midpoint, what is the electric field between the two charges? One charge having 1 microcoulomb, second charge having -2 microcoulomb. Okay, what is the net electric field? Here place having electric field is outward. Okay, electric field is outward, that means here from this electric field is outward. And also it is negative is electric field is inward, that means inward, that is ES E1, it is E2. The net electric field, the net or total electric field is equal to E1 plus E2. The resultant electric field in the this direction is like this. This is outward is electric field is are like this. Inward plus means, okay, this minus, it is inward, it is outward, inward, that is attraction, repulsion. Okay, here electric field is from plus to minus. Okay, both will be in the same direction, that's why the total electric field or net electric field is equal to E1 plus E2. Okay, according to formula, ER. ER is equal to K Q by, okay, at this point, at first charge, E1 is equal to K Q1 by R square. That is, K is nothing but K is equal to 9 into 10 to the power of 9 into 4 coulombs. Okay, here Q1 means what? 1 coulomb. 1 coulomb is nothing but 6. 1 coulomb is equal to 10 to the power of minus 6 coulombs. Okay, by R square. R is equal to 1 centimeter. 1 centimeter is equal to 10 to the power of minus 3 whole square. It is E1. Next, due to E2, here E2 nothing but K Q2 by R square. K Q2 by R square. Here K is equal to 9 into 10 to the power of 9. It is E2 is 9. Okay, Q2 2 microcoulombs into 2 into 10 to the power of minus 6 divided by R square, 10 to the power of minus 3 square. Okay, according to net electric field E1 plus E2, this equation, the total electric field E is equal to K by R square Q1 plus Q2. You can simplify total electric field is equal to K is common in the both cases. Both cases is K is common, R is common. So that is only difference is Q1, Q2. Okay, from this equation we can simplify. Here total electric field K by R square into Q1 plus Q2. That is, K is equal to 9 into 10 to the power of 9 R square. R square means 1. Okay, R square 10 to the power of minus 3 square. Okay, both having same radius, same distance, into Q1 having 10 to the power of minus 6. 10 to the power of minus 6 plus 2 coulombs. 2 into 10 to the power of minus 6. Okay, 9 into 10 to the power of 9 by 10 to the power of 3, that means square, 10 to the power of 6 into here 3. 2 plus 1, 3 into 10 to the power of minus 6. Minus 6 cancel. Okay, 9 3 ja 27 into 10 to the power of 9 Newton for coulombs. Electric field, okay, 27 into 10 to the power of 9 coulombs occur at EP. Electric field at midpoint. At P, what is the electric field? That is at EP 27 into 10 to the power of 9 Newton per coulomb, or 2.7 into 10 to the power of 10 Newton per coulomb. This is the electric field occur at midpoint between the two charges. Okay, now we will discuss electric field lines or lines of forces. Okay, that is plus Q having radially outward. Radially outward means in this case plus Q having electric field produced, it is radially outward. Minus Q, it is radially inward. That means electric field like this. Suppose the plus Q electric field is produced outward. Electric field is going. Okay, the electric field is inward. Okay, radially inward. Okay, it is attraction, it is a repulsion. Like, okay, suppose the electric field at certain point due to charge, the distance is R. Electric field is equal to KQ by R square. That means electric field is inversely proportional to the square of the distance. Here we can choosing large arrows or small arrows. Small arrows is nothing but direction of the electric field. Arrows is the direction of the electric field. That means electric lines of forces. Here suppose here only how many lines? 1, 2, 3, 4, 5, 6, 7. Another plus q charge having 1, 2, 3, only 4. That means which charge producing the number of lines can be producing. That means electric field strength. The strength of the electric field is nothing but intensity of the electric field plus charge. That is in the case of test charge having plus q, it is repulsion. We get radially outward. It is electric field is radially outward. The direction of the electric field is nothing but the magnitude of the force. That means that is magnitude of the electric field is nothing but density of the lenses. Okay, suppose here only one charge having only 4 lines, another charge having 1, 2, 3, 4, 5, 6, 7, 8 lines. That means here electric field lenses is more. That is we get high intensity, high electric field compared to here E2, here E1. That means E1 greater than E2. That means this charge producing the high lines of forces, high electric field lines compared to first charge, second charge. Okay, that is second charge Q2, here Q1. This producing the lines of forces is more, that is strength of the magnitude is more compared to second charge. That's why the electric field due to second charge is low compared to the first charge. E2 is low, E1 is high. Electric field high, electric field of strength. The lines of force is nothing more. We get the electric field is more. That is nothing but that is more is nothing but electric lines of forces. Okay, here and also same phenomena. Density. Suppose one in the textbook it is density. How many lines are passes through the some space? Here only 3 lines is passes. Another in the case of in the same area, another charge. It can be producing the number of same area. It can be producing the number of lines 1, 2, 3, 4, 5. Okay, 5 lines here. 1, 2, 3 lines. That means it is Q3. That is E3. Okay, according to density is only single at same area. We get only single electric field lines. Here 3 lines. Here 5 lines. That means here E3 is greater than E1 is greater than E2. That means like this. Okay, due to third charge, it is small area. It's small area. Both will be in the this one both will be same area, but charges is different. It can be producing the number of lines. Electric field lines is different, but unit area. That unit area or density is nothing but it can be producing the number of lines of forces or electric field lines that they having strength of the electric field. Okay, already electric field direction along the force direction. The electric field lines are imaginary. The electric field lines are imaginary lines. In this region, space-time region along which free fast charge. That means electric field lines are imaginary rays. Real is the electric field. Electric field is the real. Electric field is the real. Electric field lines of electric field lines are the imaginary lines. And also the some properties of electric field, that is electric field or electric lines of forces having some properties. The properties nothing but they originally they originate from positive to negative. It is already here positive means it is radially outward. Outward means electric field direction from plus to minus up to infinity. are long distance. They are traveling long distance. Okay, this is in the case of minus charge, it is radially inward. Radially inward means the rays are coming from infinity. It is going from infinity here. From rays are coming from infinity. That means electric field extend up to infinity. Electric field extend up to infinity. That means there's are alternate from plus charge to minus charge. Yet started from minus charge, end with negative. And also they do not form closed loop, because in the case of magnetic field, north pole to south pole, south pole to north pole, magnetic lines of forces, same phenomena we get magnetic lines of forces as well, same like here electric lines of forces. Electric field lines of forces only passes from positive to negative, not to negative to positive. What is negative is nothing but attraction. Positive means it is repulsion. Repulsion means here electric field lines goes from plus to minus. Okay, plus to minus only, not minus to coming only one direction. That is, they do not form any closed loop, and also they do not terminate in a space. That means they do not terminate in a space. Okay, it not terminate at up to infinite distance in a space. And also the number of lines of forces subject, but the density of the electric field of lines is object. That means here one charge having charge having 4 lenses. Here 1 2 3 4 5 6 7 8. That means area or density, it is depends upon the how many number of lenses pass through the is nothing but flux. Okay, I will discuss in the next class the flux. Flux is nothing but how many number of lenses, magnetic lines of forces is going from charge. Same charge it can producing, it can having 4 lines of electric field. Here 8 lines of forces. That means at small distance, here small distance it get only single line. Here it having 4 or 3 lines like this. Here the Q1 Q2 having only single line, same unit area. Same unit area we get 3 lines of forces. Here we get 5 lines of forces. That because that's why E3 is more compared to the E1 E2. That means that is number of lenses through the unit area for density, for unit area or volume. That is depends upon rays are coming or inward or outward. That is depends upon the lines of forces. That means the lines of forces is nothing but magnitude of the charge. Okay, magnitude of charge means here only single charge having 2 lenses. 2. Okay, we can increasing the charge, it can be producing the direction 2q. This 2 charges, it can producing the 2 lines. Here 4 lines, 1 coulomb charge, 2 coulomb charge. Okay, and also similarly initially 2. Okay, we can double, it can be get the 4 charges. Initially one charge having 4 lines. Okay, this charge can be double, it can be 4 to 8 can be producing the lines of forces. Okay, one problem is there. Okay, one positive charge, another one is positive minus charge is there. That is electric lines of forces from coming positive to negative only. This having 1 2 3 4 5 6 7 8 forces. Okay, Q2 having 1 2 3 4. What is the ratio of Q1 by Q2? That means here Q2 having how many Q1 by Q2? Q1 by Q2. Q1 having 1 2 3 4 5 6 7 8 magnetic lines, electric lines of forces 8. Q2 having 1 2 3 4. Okay, 4. It having charge is minus. Okay, 8 by 4 is nothing but, okay, it is 2 charges. Now net charge is equal to Q1 by Q2 is equal to 2 charges. That is Q1 by Q2 is equal to minus 2 coulombs. Thank you. 100.